here. So I just got a bunch of definitions. Like first off, like what is AI? And I just pulled the definition from Google. I promise I won't read to you the whole time, but I think sometimes reading like helps me get started and like pulling definitions and stuff. And plus, I'm still learning about all this too. So like sometimes I get a little bit hazy on the definitions. And then you could like cross-check me with the actual definitions I pulled and be like, that's not right. Like it obviously says the right thing there and you're wrong. It's like I'm good with being wrong. I'm still learning. So so yeah, so artificial intelligence, AI, what is it? Well, one of the things it is it's kind of a hot topic word that the world has, the broader world outside the tech industry has just like golfed up and just like everything's AI. And so it kind of means a lot now, but I pulled this from Google and they said their thought was AI is a set of technologies that enable computers to perform a variety of advanced functions, including the ability to see, understand, and translate spoken and written languages, analyze data, make recommendations, and more. So just kind of an intro to kind of get us in. Then I wanted to kind of narrow down the talk a little bit more, talk more about like machine learning, and kind of how I've been using it in my coursework. And machine learning is a field of inquiry devoted to understanding and building methods that learn, that is, methods that leverage data to improve performance on some set tasks. It is seen as part of artificial intelligence. And I want to stop here because some of my very light knowledge, I don't remember anything from the auditing class that I did back in 2011, but one of the things that I found was very interesting was my professor mentioned another like field, and someone correct me if I have the name wrong again, because I think I got it wrong last time, but it's like, I think it's called like expert systems, where people, they explicitly program what they want the system to do instead of like having like these models built and then letting the machine make the best recommendations. That machine learning kind of like caught fire and got super trendy and popular because I think people really found that it was probably more useful than the recommendation systems and got better outputs. So there's a ton of other methods besides machine learning that have kind of fallen by the wayside. Actually, machine learning has been around since, I don't remember the year, but it's been around for like a while, this field of study. And it's
almost as old as the computer languages themselves. They've been trying to do model the brain learning process, building out the patterns. It goes back a
long time. And so it only sort of, I don't know if I want to say recently caught fire, because it's been on fire for a while, but like I think the general public is kind of like, oh, but it's like AI has been in everything.
That critical mass again.
Yeah, critical mass. So I think, and this is like more of a question, do you think it was like the shift between, because I remember like academia, they like abandoned it for a while. Like nobody would be, if you were academic and you said like, I want to do machine learning, nobody would take you seriously at one point. What, like, I'm still unsure, like what was the shift? Was it our computation power, or?
It's probably a collection of things.
I mean, it's got to have a lot to do with computation. So making that affordable,
commoditizing that, and I think the general investment, like the open AI as an organization, is focused on just building AI as a business product. And so when you put that, it's a matter of where we put our resources. They are putting their resources to just this. And so I think that means a lot as well. That didn't exist for a long time.
Definitely. The next slide. So here's kind of like the high level. So, artificial, just to kind of help us visualize, artificial intelligence is a big circle, subset of artificial intelligence is machine learning, and then subset of that is like deep learning. I'm not very familiar with deep learning, just haven't played much with it. That's going to come like later in the course. We've just been working mostly with like machine learning stuff, mostly sort of like linear regression, logical regression, some classification problems we've been working on. So that's kind of been where I've been focused. Oh, this was the slide when I gave it before. I was like, sorry, I'm not sorry. I don't know anything about deep learning. Sorry. And then more like drilling down more subset of machine learning. Supervised learning is a subcategory of machine learning and artificial intelligence. It is defined by its use of labeled data sets to train algorithms to classify data and predict outcomes. So I think the way I described it is if you remember kind of from when I think about it, I think back to like algebra class where I'm like, here's a function, you put an X value in, out comes a Y, and the Y is what we want to find. It's like the same with machine learning. And then this is kind of just juxtapose this with like unsupervised learning where all your inputs are, I guess they're unlabeled data sets. And I think that's like the main big difference. So still trying to figure out some outcome. Where did I go for this? Okay, so in the course that I've been doing, the professor, well, it wasn't really a professor, it was like one of the, like the learning TA people who kind of come along, showed this graph. It wasn't this graph, but it was one very similar. And I loved it because for me, as a software engineer, I want to know, where do I go? I want to go from A to Z and like, what does the whole process look like when I'm thinking about building an application, or even if I'm in DevOps, like what do I want to get to? What's the system I'm trying to build out? I want to know step 1, step 2, step 3. And it was like, one of my frustrations with machine learning was I like coming to it on my own with what very little research I did on my own. It was I didn't really know how all the parts, like what the parts were, and then like how all the parts fit together, and actually like what happens when a business says we want to build an algorithm to predict such and such, like what are all the stages in a cohesive way where anyone can understand. Like my 2-year-old, I don't have a 2-year-old, but if I had a 2-year-old, if I could find a 2-year-old, I could show them this graph and they could be like, maybe 5, maybe 7, they know how to read. But I could show them this graph and it's like, this is all there is to it. And so we kind of have from left to right, you have your problem definition, and we're gonna go through these segments, look at data collection, look at data preparation and data visualization, and you get to your feature engineering stage and your ML model building. And then eventually they get to this point where they take all that, the end result, and then they have to somehow deploy into production with a pretty UI and all that stuff. So in my course, we've kind of been doing everything to the left of the purple bar, kind of like learning about that. I'm not really sure about deployment too much, so I probably won't talk that much about that.
The purple bar before deployment.
Yeah, to the left of deployment. Yeah. I guess. Oh wow, they're both purple. Sorry.
Okay.
And now I just saw it. Like to the left of the model deployment. Focus there. Not really sure what some of this looks like in production. I have some ideas, but like I don't have deep ideas. I think that would be, if you wanted to explore that more, you'd Google probably like ML ops sort of stuff.
Would that be like the app?
Yeah, like app development, just how they keep. I mean, there's still a lot I don't understand there. Like, how do you? I have a million questions still, but like, once you deploy a model, you're still getting new information, and you probably want to retrain the algorithm to be better. So like, what does that look like for production?
What does the SDLC look like?
Yeah, I'm not familiar. What's that acronym? Yes.
Oh, software development lifecycle.
Okay, lifecycle. Yeah. So still learning, and I still have tons of gaps in my knowledge, even on the left side. I'm still trying to parse apart like what stuff means, and I think being here and people asking questions, engaging, like will open my mind to even more questions. I did want to talk a little bit about tools, because I know a lot of us here Python developers, and so you're working in your Visual Studio. I don't know if people work in Vim, Emacs. You have that, and you have your GitHub or your version control system where you're saving your code and committing stuff. And data scientists, and I probably don't have all of what they use, but data scientists have their own set of tools that they use to try to wrangle all the code and try to present ideas to the business. So I opened up a few things. I owe $750 for my course, so they're blocked me for now.
Wow.
I like paying in installments. They're really rigorous on that. So like, what does the IDE look like for a data scientist, like machine learning engineer? Also, I'm kind of using those terms interchangeably. They're not like exactly the same things. I'm still drilling down to like, there's like the analyst and the data scientist and who does what. It's all, I think that space I need to like clear out a little bit more. I think the machine learning engineers do more of like coding, and different stages have different people involved in that like previous graph that I showed. So a lot of it's like handoff to people. Like over here, it might be more like software engineers like us.
Maybe UI, UX people.
Yeah,
on both
UI,
sides.
UX people at the end. Over here, you might have problem definition, might be it's business. And then you might have a bunch of analysts who do something over here with the data collection. They're passing that off to like a data science who probably gets these two buckets right here, which is like really four things. So there's all sorts of people in there. I don't think there's a lot of shops where it's like one person just like owns it all, but that would be cool. There probably are shops like that, but I'm not super familiar. So one of the tools that they showed us was this one called Google Colab. So this is just a tool where you can kind of put your code. There's sections so you could put
So
mark.
you're not sharing.
Oh yeah. I'm not sharing the whole screen. Thank you. Okay. Resume share. Nope. Click this one.
So there's like a janitor or someone here that's like whistling and opening and closing the door. Okay.
It's a ghost. So this is one tool. It's called Google Colab. Downside of this tool, your data, if it's proprietary and you have to upload it to this, it's in Google's cloud ecosystem, which I don't know if you trust them or not versus keeping it on your local machine. That's probably a downside.
You could also be using the Google's cloud ecosystem to do the actual like crunching of the model anyways.
Yeah, that's true. So
Like,
they
it's
probably
gonna-
have
it's
your
probably
data
gonna end up in
anyway.
some cloud. Yeah.
Exactly. So this allows you to kind of do some markdown, and then there's some code over here that you can like execute. You write your code here, and
So you probably haven't heard of Jupyter Notebook.
yeah, that was my other one.
This looks like a Jupyter.
Yeah.
It's basically synonymous with Jupyter Notebook. This is just
Okay.
Google's
It's probably
version.
Google hosted Jupyter Notebook.
Yeah.
Jupyter Notebook as a service.
Exactly. So the other one was yeah. The other one was I found this tool. Well, I didn't find it. The class presented this tool called Anaconda, which is where I pulled and downloaded Jupyter Notebook. It has like a whole ecosystem in it. So
Have you ever used Anaconda?
Very lightly. I haven't
Okay.
really dug into it,
Yeah, me neither.
yeah,
but it is package management,
Yeah. But
but very like for
what
specific
type
use
of
case.
packages?
Data science.
Okay.
It's data science specific. Like I don't know why Anaconda, why they
Okay.
didn't just leverage the PyPy,
Right.
but
Okay.
for whatever reason, Anaconda has its own set of packages that it manages,
Right.
and you use it just like PyPy.
Okay, now, and am I going crazy? Because there was a tool called Anaconda that helped you install Red Hat-based Linux distros. Does that sound
I'm not
familiar?
familiar.
Okay, because
It's entirely possible.
it's sort of like an automated install thing before. Yeah, okay.
they
I swear it was
overloaded
called
it.
that. Right.
It's
Probably
entirely
was,
possible.
So this is how I ended up downloading. This is just how they had us do it in the class. So I just did it that way, and then you can launch or use whatever else you want. Yeah, maybe that's part of it though, because it's like
Well,
because
it's
PyPy you have
also-
to run the command.
Well, it's also a command line.
Yeah.
Oh,
you could do it. Okay.
I feel like I don't think that you can install Jupyter notebooks from PyPy. I think it's more libraries than applications.
So what do you mean installing Jupyter Notebooks? Like the application Jupyter?
Yeah. So
Oh, like it might take some non-Python dependencies?
or non-Python or just system configuration type things
Okay.
to actually do the installing.
Yeah. This one. There's a PyPy here,
Yeah.
but
So
it's Viola. Interesting. I don't
Ah.
remember. Oh, it's, what is it?
Voila.
Voila. Okay. I'm not well versed, but yeah, it's neat. Um, yeah. So there's this, and then there's I never know how to say it. I say GIF or GIF. It's like Kaggle or Kaggle. I don't remember which one it is, but this is just a resource where you can get a bunch of like data sources to start working on machine learning programs. Cool. So I think I pulled this up one recently. Fun fact about me: I like machine learning. Wow, I like Magic the Gathering. So I was like, oh, I could pull this data set and do some sort of fun little thing. But the cool thing about this site is they have competitions too, which is cool, where you could try to like compete with other people who are making models and cleaning data and stuff like that. But there's also like ways to like pull down, maybe it's in the code, new notebook. I think this is it, where you can click on these and there's like a way you can download other people's Jupyter notebooks. So if your company has a similar problem set that you're trying to do, like you could just be like, well, what was the algorithm that they used and how did they analyze the data to solve their business problems? You could just be like copy paste and change it and use it for your own organization's purposes. So that's the tools. And somewhere over here, I forget how it organizes anything. This is my Jupyter notebook for one of my projects. And so I was gonna kind of walk through some of this. I guess we go next, tools, data collection. So I kind of talked about data collection a little bit. I guess if you're doing your own fun side project, like you just go to Kaggle and you download like a big CSV file and do stuff there. Obviously, you probably get some data from your business who wants you to do a problem. And they're like, here's the data. And so that's part of it. A lot of it goes into sort of when the business hands data to the ICE individual contributors, the hands and feet. A lot of times that data is going to have problems. So you can't just use the data that you're given to like just shove it into a machine learning algorithm and then hope it comes out with something intelligent. You know, I like to think garbage in, garbage out. You know, you put crap in your car, it's gonna be a crappy experience. If you put good fuel in your car, it's gonna run a little bit better. So a lot of it's going back and forth with the business and say, we need this, or, you know, we have questions about this, and like clarify how this is going to be used and things like that.
There was an article, I think in like early 2021 about the failures of ML with diagnosing COVID, and like how like the engineers got all this data from like hospitals, you know, like CAT scans and X-rays and things like that, right? And these are just like hospital people doing their jobs, right? But there was such disconnect between that. The models were trained. The training of the model was a complete failure because they didn't know any of the nuance of the data.
Yeah.
And it's almost like they were better at detecting whether a person had the scan when lying down or standing up than detecting COVID, right? Because it was just like, you know, they got a whole big training set with one style and a whole of another style, and like, I mean, I don't know the details, but yeah, because like engineers don't know anything like how it's going to look differently if the person's lying down and stuff like that. Or,
the data engineers or intake or whatever was so disconnected from like the people collecting the data. Totally different organizations.
I was just saying, I did a survey for my company, and like there was like 4 options recently, and I was like, I don't know how to interpret this. So I'm just gonna say all the best option when I'm reviewing this person, because I don't want to like there's no like I haven't had experience with this person, so like, you know, I don't know for this parameter. So I was like, I'm gonna assume the best. And those situations could happen where they're like, I don't know, like the doctors, the nurses, they're trying to deal with a global pandemic. Like, how many people did you see this day? It's like 12 to 50. Let's split the difference and call it 24. And then that goes into your algorithm and like, woohoo, like it's a magic box.
The engineer doesn't know that they need to ask about whether they're standing up and lying down, and then like the person taking the CAT scan doesn't know that actually matters to the engineer. Right?
Yeah.
Yeah.
So Yeah, that brings up another point. Just like there's a collaborative piece, which we kind of figured out in our industry. Like it used to be, hey, how cool is it that we have this solo, 100x engineer who like works by himself? But then we figured out like, oh no, it creates other problems. Like we have to work together.
Yeah.
The business,
Single point failure.
yeah. So seems to be quite true in this realm as well. That's cool. Data preparation and data visualization. So you get the data, you ask a bunch of questions, you fight with the business a little bit, and then there's this like feedback loop of data preparation, data visualization, and I was going to kind of shift back to here and kind of talk more about that. So, and maybe part of this will also be the data collection piece. So I get the data. So now what I want to do, I want to start my machine learning project. So this is an actual project I had to do for, and also disclaimer, I did not get 100 on this project. Like it's a project that I did. I tried to do the best I could and with the knowledge I had, and it could be a lot better. Like there are insights and inferences I could have did better, but this is sort of like the template I kind of use for the talk to kind of.
That's always going to be the case.
Yeah, that's true. Well, thanks. Yeah, so, but I thought this one was interesting, so I thought I'd pull this one in. Started with my business problem from the business, problem statement. So the problem that we had was, it's called a Cars for You problem. So the problem they presented us with was in the Indian car market. Apparently, there's a huge demand for used cars, and the problem was trying to figure out and help the business to optimize what price that they kind of recommended that they wanted to like sell the car for. So you don't want to come in and be like, we think we can get $10,000 for the car when the car's worth $7,000, because if you throw $10,000 to the customer on the, when they're signing the deal, yeah, they're like, see you later. Like that's ridiculous. But if you do $2,000 and it's worth $6,000, like you're leaving all this money on the table. But yeah, but now you have all this historical data where you're like, oh, I know what the car sold for, and I know what I could get for it, and which I just thought of like a problem with that, because it's like, well, you don't know if you optimize. So yeah, there's already a gap. Like I don't know, is that the high price? Is that the low price? Like I'm just like, I should have added that to my yeah.
It's always a rabbit hole of detail that you go into.
Yeah. So that's what that problem, this problem is. So the data that they gave us, so this is just a little information about it that I took from the homework page. So these are all the columns, and I guess I could print these out, but they just gave clean descriptions of it. And we can already see it's like, oh, if we want to predict price, what would maybe be useful? Well, we see like a serial number and you think like, what's that? It looks like it's some sort of ID, and it turns out it is actually like a 1, 2, 3, 4, 5. It's like, that's not really predictive. So that's probably not super useful. So already like we're looking at the data, we're already thinking like we could probably throw that out. There's names that could be useful. There's a location, year, kilometers driven, fuel type, different things. And then we have, so what we're trying to predict are like Y value. If we think back to algebra, your X value is what you're putting in, your Y value, what you're getting out. I guess what we're trying to predict is the price of the used car. And I think it's pronounced Lonks. I forget. I think it's Lonks. Someone correct me if I'm wrong. So yeah, so we're trying to, I keep doing that. I keep forgetting it's not a PDF. So we're trying to predict this, and we have what it sold for. But they also gave us like the used price, so this is the used price that it sold for. They also gave us the comparable new price of what that car would have sold for if it was new. So that could be a good predictor, because you would think like, and a lot of it's just sort of like, I call it like common sense reasoning. Like you're kind of thinking about how you would think about like anything, you think to yourself, well, if the car sold for like really low new, it's probably not going to sell for that high used. If it's sold really high used, like it's a Lexus or it's a, man, this happened last time. I can't think of any luxury car brands. Mercedes, it's probably going to sell for a comparably high price used, because luxury cars. But I could also be wrong, because it might turn out that like, and I didn't explore this, and this is another area I could have explored, but it might turn out that like luxury car buyers don't like to buy used luxury cars. So it's like, I think it's super predictive, and I'm making assumptions already, but it might not be. And this is like kind of where things are at. So also, I don't know how much time I have, and I don't want to like, last time I got really, how are we doing?
Yeah.
Okay.
We generally go until about 9 or so.
9? Okay, cool.
But the timing is loose.
It's
Try not
loose.
to go beyond 9 because
Okay.
people start to fall asleep.
Cool. Sweet. So, and yeah, just feel free to, chime in if you have any questions on the video side too. So, import necessary libraries. So these are just some of the libraries that I imported. So you have NumPy, which is a very popular Python library, adding like support for like, you need these multi-dimensional arrays where you could do different computations on the data. You have Pandas, which is a library that lets you do different data manipulations and analysis. You have Mathplot and Seaborn, which Seaborn is a library that lets you do data visualization. So you get your pretty graphs, you get your box plot, you get your, I don't know what other graphs. There's even like a weird 3D graph that I'm like, that looks super cool. Don't know how I'd use it because I've like never seen anything like it. It looks weird. Yeah, if you want to do a hologram or something, which is super cool. There's some other libraries I pulled in here. I think this one was a linear regression problem. So I pulled in, there's a library, scikit-learn, or how do you say it? Scikit. Yeah. So it gives you this cool tool that lets you like split the data when you're trying to say like, when you're trying to like segregate the data, you want to say like 70% of the data is my training data and 30% is my test data. You want to split it out like that will like, it has some tools in there to like kind of let you do that. And then this is like the model that I use, so linear regression. You can import any other models that you want. Mean squared error is for checking like the performance of your model, like how well it did in evaluating and scoring it. That's an area that so I took a stats class ages ago, and some of this seems familiar, but like I'm still like brushing up and rereading all the math stuff because I just like haven't worked in it in super long.
Why the training test split? Like, what is the benefit to segregating portions of the data?
Yeah, so that comes into play when we do the actual like model building. So for the example is, we know in this data, we know the question and we know the answer. We know the inputs and we know the outputs, but we're trying to build a machine learning model where we're trying to predict some unknown variable. Okay. So to kind of pretend
known and unknown.
Yeah.
Training set, and then the set that you're applying.
Yeah, which is the test set. And so we want to use most of it for the training set. So they say about like 70%. I think you can use 80%. It's up to the discretion of the data scientists. I think there are best practices out there. Says you look at like, well, how much data do you want? And do you really only want to do 70% if your data is like super small or something? Maybe you want to do 80%.
Yeah, but I was going to say higher with a smaller end.
Yeah. So you do either 80% or 70%, and then you're going to build out your kind of your model, and then you fire your test data through, and it's going to say, oh, I'm going to put in this unknown X, but the model knows like I actually know the end value, and then it's going to predict like this one or that one, and then that's kind of how it knows. So something else I was going to say on this piece regression model. Oh, maybe I'll get to it. And then there's these things which remove the limits from the max display column. I don't remember this at all. I think it's a minor thing. I think it does what the comments say, but you can see how when you walk away from it, all the information just like kind of seeps away. It's here. So when you kind of start out, you get a big CSV file or maybe a couple different files, and you're aggregating and you're trying to put it together. So this is the CSV file they gave us. And so I used, I think PD's pandas to build a, to import that CSV file into what's called a data frame, which is, it's a, I guess it's an object that you can kind of manipulate to do computations on your data set. And it's sort of optimized. I think there's two. I think there's the data frames, and then I think there's another way to like do it. But I think this is like optimized to be fast and efficient and do all the things that you want. And also you get a bunch of like method calls that you can do different things and get different insights on your data high level. So in this when I loaded the data set, I said load data set, load it into data, and then I took a copy of the data frame and put it into this, as opposed to just manipulating the raw data itself, because like later down when I'm working, I might be like, oh, I threw away this one column that I thought wasn't useful, but then this one case came up and I like want that other column, and now it's gone because I deleted it. And you're kind of running all the code like in the Juniper notebook like sequentially. So if I go up here, actually if I run this should fail. Yeah, it fails because it's dependent on all the code above it. So I have to run all my imports, and then I run this, and it found the file.
Is there a shortcut in Jupyter Notebook to run that block plus everything above it?
Yeah, so that block and everything above it, run all above, I think will do it. Yeah.
But it's not a shortcut. I need a keyboard shortcut.
Ooh, I don't know if there's a keyboard
I
shortcut.
wonder if there's you can configure the menu.
Probably, yeah. Yeah.
Imagine you might be able to make your own shortcuts.
Yeah. So for the projects I've been doing, since they're so small, compared to like what organizations will do, I just do run all a lot of times. Sometimes it'll hang, like, because it'll try to process them all. Like if I do run all real quick and then I go to the bottom. So these are still processing because they have the star. So it takes a while. These finished, then I go back down here, then all the stars went away. So it like ran everything sequentially. But that would be good if there's a shortcut for that. So head, it just prints the first 5 columns of the data. And so this will give us sort of a kind of a high level of like, what does the data kind of look like?
I think you can do just DF, and it'll do like the first 5 and the last 5.
Oh, with this one?
Yeah.
Ooh, good to know. Just
No?
DF? I don't know.
That was what I thought.
Oh, yeah, it was just thinking.
Oh, but
solid.
It's printing, maybe it's more.
Everything.
Everything.
Okay, I don't know. Sorry. I've definitely seen that for large data sets.
There's also a tail, which will give you the last 5.
Yeah, so it must have been doing like maybe the first 50 and the last 50 or something.
Got it. There's also like other like settings or ways you can configure it like ahead of time to make it do different weird defaults and things like that.
Yeah.
But this kind of gives us like a little bit of knowledge, insight into the data. First off, you'll see like, why are all these prices missing? That's a problem. You know, where are those numbers? How are we going to handle that?
I like that owner type is a number, but written as a string.
Yeah. That's like another big thing. Owner type is a string. Mileage, wherever it is, that's a string, but it's a number. Like,
oh my god.
So
I'll forget this. I don't want
So
data cleansing.
yeah. So it turns out all the fun stuff that people talk about when they talk about data science, all the model building is just like 20% of the whole project. Super quick. The long, laborious, may I say, sometimes boring part is cleaning all this out. Like, this is the stuff nobody wants to talk about. This is 80% of your time, and it's not
traditional ETL.
I like it. It keeps me employed.
Yeah. No, I actually do a lot of it myself.
Oh, data engineering type stuff.
Yeah.
Cool.
Yeah, lots of back end connecting systems.
Yeah. Extract, transfer, load. So yeah, we have to clean it all up. I might run through some of these quickly because they're kind of self-explanatory. So this, sometimes you'll have duplicates in your data. This is checking for duplicates. There's 0. If if there were duplicates, there's like a command to drop the duplicates. So that's something you can do. Doing more data analysis on it. There's this shape method, which will give you the number of rows and columns, which kind of gives you the size of what you're working with. Yeah. There's this info one, which gave us all that info that they gave us without the descriptions. And as you'll see, we have mileage. This is like a kind of like a, oh, these are red flags. You look at mileage and you're like, that's a number, it's an object. Engine, number, object. And that tells you like there's some data in there that's making it not come out as a float or an int. We need to look into that and do something about it so it comes out as a number like we're expecting. Even if there's nulls or whatever else in there, we still need to handle those. I really like this. So this is this is describe. So this gives you like kind of a statistical overview of what's happening in the data. So it gives you like a count for the columns. It gives you the top, like most frequently occurring things. So this says diesel. I guess the other one would be like gas. Manual, I guess the other one would be like automatic, I'm guessing. And then frequency, how many times, and the mean, standard deviation. I don't like this view personally, so I use the dot. It's called T, and it transposes it, so it flips it. And I find this easier to read personally, seeing my stats on top.
Absolutely.
So that's something that I just do. And then, so we start exploring the data more, pre-processing. So a lot of this is called like, as we're getting into it, it's called EDA, which is exploratory data analysis. So we're looking at the data, we're trying to understand it, we're trying to kind of clean it up, and we're trying to like build graphs to kind of get reason about like what's happening before we actually get to the model building piece. Because a big trendy word that you will sometimes hear with these algorithms is like explainability, where it's like, WTF, what does this algorithm do? Data scientists, we have no clue, or probably engineers, I don't know, like we put some stuff in it and stuff came out, and that's the truth. It's like, you know, they want to know why, especially for like compliance and things like that, like, you know, so. So we explore missing data values. This is sorting the data values, checking for nulls. There's a lot of nulls in these columns. So I probably should have handled them in here. I can't remember if I actually did or just said I did and just submitted. No, but I'm sure I did something. This gives us a random sampling of a bunch of different things, so you can get a wide view of stuff. Scrolling. This is not in a prices dependent, so we can drop those. Checking for nulls or sorting again. I feel like I just did that above. Yeah.
Well, so you dropped the nulls that were in price, which makes sense, and then you're just checking again what is left. How many
Yeah. Cool. It's been a minute. Let's see.
I find that notation interesting.
This one?
The square bracket notation.
Is there another notation?
No.
Okay.
Just, I'm not used to it used in that way.
Mm-hmm. Have you not played with like pandas or NumPy?
Not really.
Yeah. It's common. You get, yeah, I don't know. You get used to it.
Yeah. Okay. It's kind of used like the parens.
Well, you're thinking you have like a matrix and you're just like selecting columns from a matrix in the same way like you select items from a dictionary.
Yeah.
So instead of the output, when you select an item from a dictionary, up with a single field, the output is the whole column.
Okay.
So it's sort of intuitive like that, right?
Got it.
Yeah. So yeah, I guess you'd expect like a 0 or a 1 or something here. I think it might actually work out if I do 1, 2, 3, 4, 5, 6 for a 0 base.
So like, yeah, these like back-to-back brackets. It's like you take the whole data frame and you just want the seats column. Or
the seats.
No. Okay, well, we'll start from the inside.
Is it like a matrix that is getting passed?
Yeah. So you're pulling out the values that are NA.
Yeah.
Like the middle one is creating a single column of true false values.
Yeah.
And then you're applying that column to the whole data frame to show only values in the data frame where is NA, where seats is NA. I don't know if that's
Well,
Yeah.
yeah, no, that is what it's doing.
yeah.
And over here, I guess we dropped the NAs in place.
Okay.
I guess I dropped the column for the number
Drop.
because I didn't think the serial number was very useful.
But so any NA anywhere in the row?
That's a good question.
Let's drop the missing values. Really good. With reasonable data. I mean, oh, I see.
Yeah.
Yeah, we just threw it out. We didn't want to. I guess you have enough non-NA data that it's not
To do stuff on it.
significant.
Yeah, I wonder what the scroll up.
Scroll up.
Yeah.
A little bit.
So-
Going, let's see, what was
The total was like 7,000.
Or up here.
yeah, that. I wonder what the transposed looks like now that you got rid of the NAs. The describe.
So
Keep going.
it's
Right there.
right here.
Yeah.
Cool.
Yeah. Oh.
Wonder why they're unique and often frequent with price.
Well, maybe for integers and floats, unique. They don't get you any strings.
Yeah, there's a lot of unknowns for me. More research.
That seems to be the case.
Yeah. So you the next one is you don't think number of seats is that serial number?
Serial
Never mind.
number, yeah.
Yeah.
Seat number, serial number. Okay.
So I just dropped that one. These, I didn't think I wrote these. Or did I write these? I can't remember. I think they gave these to us. Remove units from values, so that maybe I did write this. I think it was in another one, and I just sort of adapted it to this. But yeah, so I was just trying to turn
this is not a learning data science when converting strings of
Yeah.
kilometers into integers.
Yeah,
I'm fine with
yeah.
having someone else do that.
So bunch of integers, bunch of floats, converting stuff to reasonable values.
What you need is to make a model that can interpret the string and output the right integer.
Yes.
Yeah.
There you go.
Model inception.
Drop vehicles where mileage is 0, since this doesn't make sense for the vehicle to use.
Yeah.
So some of these are like assumptions I made. So don't take this as like he did the right thing. Just take this as like he did a thing because he made it. Yeah.
Yeah.
So, okay, cool. I think I was trying to get to this point because okay. So we did a bunch of data cleaning. Debatably, there's probably more data cleaning I could have done. Debatably, like some of the missing values that I threw out, I shouldn't have. And I should have just took like either an average or like, if it was more of like a classification problem, I'd do like a median, or maybe I should have handled it in a different way. I'm still not.
So like fill in the missing missing values with a model based on the rest.
Yeah. But that gets tricky because it's like, well, now you're changing the whole, like how the model's going to interpret it. So there's a lot more statistical grounding that I just need to work on.
The important thing is like when you're throwing out the data, like you still have almost 6,000 samples, which is probably enough. But like by removing a set of that data, you have to ask like, are you introducing a bias, right?
Yeah.
Like, is this just a purely random distribution of data that I'm removing? Or is it like, oh, actually these tend to be lower priced cars that have this data missing?
Yeah, and they're correlated, yeah, which could have happened.
Yeah.
So yeah, so that's the data preparation. I don't know how I jumped here, but like you kind of data preparation. I kind of in my Jupyter notebook, I jumped straight to feature engineering. But one would hope that I would do a little bit of visualization to kind of like look at the data like here. So I think that was the first visualization I had. So over here, I'm just saying, do like a histogram of, looks like all the different columns to get a feel for like the data some more. So over here, you know that most of the cars are manual, not automatic. Most of the cars had one owner type. Very few cars had 3 or 4 owners. Wait, I don't even know if that's, oh, because these are out of order. First, second, yeah, third. First, second, third, and then I guess I just have fourth and above. We know that the mileage is normally distributed. Well, I don't know. I guess that's kind of normally distributed. I just get confused, like how far can these gaps be before it's like not normally distributed? That's like a stats question. Yeah, just getting a feel for the data. So kind of data preparation, visualizing data, trying to understand it. And then hopefully once we have a good understanding of our data, we can do a cool thing called, oh, it wasn't up here. Was it not? Did that, it was farther, sorry. I know it's showing me that. That's not the one I want. Yeah, so once we do that, we can get into, so we know what we have, we know how it looks, we've cleaned it up, but now we want to sometimes like extrapolate sort of like new insights from the data that the data itself doesn't really convey. So that's called feature engineering. And the benefit of feature engineering is when you engineer a new feature and you put it through the model, sometimes the model will perform a little bit better than if you just give it like the raw form of the, the data that you.
It's like doing multiple passes to kind of pre-compute some things.
Yeah. So, and it makes it more efficient. So the example that I did here was, I don't know where my mouse is. Did it just disappear? Was it? Do you see it? Oh, it's right here. Okay. So the one I did was, I decided that I thought it was really bad and confusing. I don't like the word bad or good. They're all subjective. I thought it was confusing that the name had all this stuff in it. And what I really wished that was in this data that wasn't, that was in this column, was the make and the model. And so you have this Mahindra KV, you have this BMW X-Drive, and I wanted all that. So my feature engineering task was to, that I decided for myself, was to, sorry, I have it up here. I don't know why I'm scrolling. Use the tools. Was I was gonna try to, so I thought it was gonna be very annoying to sit there and just look at every 7,000 thing and be like, this is the make, this is the model. Also, I don't live in India. I haven't gotten to visit. I'm sure it's awesome, but I'm not familiar with Indian makes and models. I only know some of the American companies. I don't know all of them. So I was like, I'm gonna need like more of a helper. So I went to GitHub and someone and this is where I reached out to the internet and was like, I'm gonna find someone who knows more than me. And I saw someone was very kind enough to list all the makes and models. But again, these are not all the makes and models. Some of the Indian companies were missing. So for those, I kind of did this high level match on these makes and models. I actually, I think I converted them all to lowercase so they would pattern match against the data better. Yeah. And then I had to get rid of all the dashes in the names and all the spacing in the names. And then I was like, do this pattern match. Oh, and then the other fun thing was, this this Maruti, and I think it was Maruti, which I don't know if I took out Suzuki. I probably
You have some
encoded
things
those.
down below.
Yeah, so I replaced some things. So there were different makes or different models that were like the same, but had different names depending on country, and I had to be like, these are the same.
Well, but maybe in India, they will pay more for a Maruti than a Suzuki.
That's true. So maybe I shouldn't have done that. So
Like, is the logo different on the hood?
yeah.
Like the Skoda is basically VW.
Oh, is it? Okay, so that's like one I could have did or not did, depending on, And so these are like points where I would go back to the business and be like, okay, question, like, how do you feel about this? You're the experts. I'm just
crunching numbers.
I'm just crunching numbers here, exactly. So I did all that. I dropped some stuff. And then I did one other feature engineering thing. So instead of saying, and I don't understand why this makes a difference. I guess I do understand. So the car, because this is like one I stole from the professor, where they, instead of saying like the year something was done, they subtracted like the year, like the year for the car, they subtracted like in another data set, they subtracted the year from the current year to get the difference, which will give you like the specific number of age. Yeah. So I guess that's slightly more efficient than, I don't know. I think maybe in some data sets it matters. I don't know if it matters so much here.
I would imagine that that's a more actionable number than the year.
Yeah.
I don't know, but if the model is just treating the number, like, does the model, basically it's like how high is the number?
I think it's just easier to work with, easier to conceptualize.
Sure.
Like
it helps with explainability.
In an equation.
It definitely helps you compare it year over year.
Yeah.
In the future.
Yeah.
Right.
How do you use 1980?
Yeah. No, that must be true. Like if you want to reuse this model, then all that year data has different meaning a year from now.
Yeah.
Whereas the age data wouldn't.
Yeah.
So but those were my two little feature engineering things I did. I probably could have did more, but I was lazy. And I think I only did the make. I did not do the model because after I got done doing the make, I was like, this took I don't know if it took me a while to do it. And I was like, I don't want to do this for the model. And I don't care about my final grade if I'm gonna get 3 extra points for doing the model, because I was like, I still have a lot more to do.
3
and
extra
like
days of work.
Yeah, if I have time, I'll come back and do it. I think I even said it there. I was like, I could probably do this, but like, I'm not doing this. Because I kind of get the gist.
What car database doesn't separate the make and model anyways?
Right? Just jam it in the name. Like, why don't you have that? Yeah, not good. So that's
putting first and last name in the same field.
Exactly.
Yeah. So that's the feature engineering, and then I guess the model building. So this is the fun part, and I'm kind of getting towards the end. Oh, this is a fun thing I might as well show. This is a heat map, but it's doing the correlation between the variables. So kilometer driven has a positive correlation. Apparently kilometers driven is highly correlated with kilometers driven, and like everything is highly correlated with itself is what the purple means. But then there's other things,
No, I just said cool.
Yeah. So there's other things, like it makes sense that the new price is highly correlated with the used price. Like that intuitively makes sense. It makes sense that
Where's mileage? Yeah, mileage has a strong negative. Oh wait, mileage and engine. Wait, no, that doesn't make sense.
Mileage engine?
Yeah,
I don't know why that's negative correlated.
Well, engine's a string anyways, right? So I don't know.
Oh yeah.
Maybe that doesn't even make sense for strings.
Yeah.
But yeah, price and mileage is only
new price and power.
I remember the other data set. The other data set that they did with the group was housing data. Sorry, this is just like a feature engineering thing I thought was cool. So they had number of bathrooms, number of bedrooms, and then like if there was like a living room and all that stuff, and they just added them and was like number of rooms total. That's our new feature engine. We don't care about, that'll predict the price. I was like, that makes sense. Like we don't have to care which rooms. It's just like the house is big. It's got 20 rooms. That's a big house.
Yeah.
Interesting. 10 closets though.
Yeah.
If you're a college student, it doesn't matter. 'Cause
Yeah,
it's
there you
the
go.
Closets or the bathroom.
Yeah. And then, there's probably better ways I could have did some of these visualizations by like rescaling the figure size and things like that. But I think that was the only other cool one. This is a box plot, stat stuff, outliers. But if there's a lot of outliers, is it really? How outlier-ish is it? So last piece, I guess, in this progression is the ML model building. And I just kind of wanted to show you just how sillily, it's not even a word, sillily simple it is. You basically have your inputs, your X value that you put in your function. It's all the data except the Y value you're trying to predict. Then you have your Y value, which is where you're trying to predict, which is the price. So you just drop the price from the data X, those are your X values. Then you take the price explicitly, and that's your Y values, what you're trying to predict. And then I'm doing the dummy thing. I get dummies. I forgot what this does. I thought this was the one hot encoding. I'm gonna skip that for now. But this is the actual, like, this is everything you basically need to train. This is the whole model, essentially. All that other stuff was cleaning, inferences. You're basically taking your X values and you're saying, split the data, like I was talking about earlier, 30% is going to be your training data, or sorry, 30% is going to be your testing data, 70% is going to be your training data for the X's and the Y's. And then you just call the linear regression model, which is a model that someone made. Or I'm assuming there's got to be some way to like, say like ChatGPT like publicizes their model and like, I want to use that. Like, I think there's some format where you can just like, I want to pull in that model and use it. Then you just fit the model with your training data and for your X and your Y, and then you just like score it and see how well it does, and then you can start predicting stuff.
So scoring it basically applies a value to each row. Or applies a predicted price.
Yeah, I think the scoring is like how well it did when it tested the test data.
Like how confident.
Yeah. So like if it put the test data through and it was like 90% accurate, it's like, oh, that's pretty good. But it's like if you trained on the training data and you put the test data, which is a subset of the data, and you only got like 20% accurate, like that's super weird. And you have to like go back to the data.
Right.
Yeah. So I did a bunch of stuff here. I don't even remember what I did. I was on a sleep fog. I was trying different techniques to see if I could get the result, I guess the score to be higher. But there's probably a chance I made a mistake. One thing I didn't really test was there's this concept of like overfitting and underfitting, which is really an issue in a lot of these machine learning algorithms. The worst case of overfitting, like the most base case of like to show you how bad overfitting can get, is if you're familiar with a classification tree where it's like a binary search tree, like just, and it branches out, those could get like fully overfit because you could get 100% accuracy on your training data because you just build out a node for every little result. Yeah. And so it's like, that's cool, but then when you have a new data point, it's too tailored to the specific data you gave it. So, so that's something you got to look out for. But yeah, that was mostly my talk. And then I was like, feature engineering, and I was like, model deployment. I haven't done that. Stay tuned. So maybe I'll do that. But yeah, that was it. That was
Awesome.
it. Yeah.
Nice.
Yeah.
Nice,
That's
nicely
helpful.
presented.
Yeah.
Thank you.
I also was interested to see how the Jupyter Notebook works.
Yeah.
Because like I've dabbled with these, and I took a big data course also during the pandemic. Had a lot of time.
Yeah.
And I'm kind of dabbling with Jupyter Notebook. I'm out on the weekends every now and then. So it's nice to see how it all goes together like a sequence.
Yep.
Like
Yeah.
a literal notebook, like
Yep.
like a project like 1, 2, 3, 4, 5.
Yeah.
It's like save command line commands or save
Yeah.
blocks.
Yeah. Similar concept to a SAS program.
Right. Yeah.
Yeah, I really like Jupyter. It's cool to be able to like as a software engineer, it's like, oh, show your work, and it's like you do all this work, and it's like, it's like the application's what you get, or you get your infrastructure all set up, and it's very like, it's not very tangible. It's like play with the app. You like it? Is the UI good? Here it's just like, oh, I can rerun it. I can pass it around. People can add their own insights and pass it back.
Yeah.
So it's kind of cool. And I feel like business stakeholders can get like more involved. I mean, some of the math stuff might be like, whoa, but it's like there's words in here. Like, this is what this is doing. This is what it's like.
It puts a narrative to the code.
Yeah.
Yeah, and I feel like most people from the business could easily understand the EDA stuff with all the graphs. I mean, it's pretty elementary.
Helps
Sixth grade stats concepts.
Yeah. They might actually understand it better, like on the business side. Like, this
exactly.
correlation,
It helps to tell the story.
Yeah.
Yeah, they'd probably be able to explain it better than more technical people.
Yeah.
Other times.
So,
Cool.
yeah.
Awesome. Thank you very much.
Thank
Yeah,
you.
thank you.
Yeah, I'm glad I got to join.